Thanks for listening, and it's a great honor to stand here for sharing. My name is Qinghao Tang, security research from Qinghao 6. So, in last May, since the rush of women vulnerability, large numbers of public cloud vendors have been deeply affected. After systematic analysis, I was interested in this vulnerability because it's, and I wonder that if this kind of vulnerability can be found in numbers at one time. So I start my research. Besides that, start sharing, let me introduce my team. Qinghao Marvel team is the first professional cloud computing virtualization security team in China. My team are focusing on researching about techniques of attack and defense in mainstream virtualization system. Recently, we have gained significant achievements in virtualization fuzzing framework, guest machine escape technology, and high weather vulnerability defense product. Today, I would like to share the following research achievements with you guys. The theoretical foundation and the details of virtualization system fuzzing framework and its running process and key problems we faced and how I solved with them at last. And later I will also show two cases which contains more details of hardware device emulators vulnerability discovery technology. And I hope I could bring new thoughts to you guys and help you discover more and more vulnerabilities in virtualization system and cloud computing system. We want to, since it will make cloud computing more secure. And on the other hand, I hope more researchers can go to this work. And beginning, let's talk about cloud computing and its brand new attack surface. Along with years of development, cloud computing has been turned from simple conceptions to specific productions. Especially, cloud computing is playing more important role in enterprise framework, such as photos, images, audio, and communication content related to individual privacy, website code and database information related to business, as well as data of governments, commuting data, and military use. Above all, this data are stored and utilized in cloud. Cloud can be divided into private cloud and public cloud. Famous public cloud service provided such as Amazon, Ali Cloud, and they provide enterprise online services. According to private cloud, they are deployed with internet network of enterprise used for storing core data. Virtualization techniques plays a vital role in realizing cloud computing conception. It can allocate physical resources dynamically and flexibly. The main virtualization system include Zen, KVM, and VMware. The VMware product series are mostly used in private cloud environment because of its strengths in product maturity. While Zen and KVM products are popular in the public cloud solution. We could see that virtualization products are still in procedure of development. There are mainly two development trends. Native virtualization and the tiny hypervisor. However, it's really hard to say one of it, which one if both two trains can turn to be the main directions. It may need more time to reach the conclusion. Servers applied with virtualization technology are completely different from common servers. One or more virtual machines can operate in the virtualization servers. Additionally, all these virtual machines can work independently. Most of the functions are provided by physical devices which are necessary in virtual machine operation, such as CPU, MMU, adapters, and keyboard. They are provided in virtualization system as software services. Hard or physical hardware functions can be virtualized. We can see that it's really amazing and advanced. However, maybe we are facing big security risks when we do this. Before this revolution of cloud computing, hackers always attack physical servers. However, recently, hackers would rather directly attack virtualization system. They slurp into guest machine and launch attack to server and the core network. We call this kind of attack as virtual machine escape. Virtual machine escape is the most dangerous and brand new attack in cloud computing environment. There are 3 steps for launching virtual machine escape attack. Firstly, entering virtual machine environment by running cloud servers or through web attack. Then, making sure the types and the version of the virtualization system by collecting information in the guest machine. Finally, complete the attack by utilizing vulnerabilities exploit tool, and they can control the host machine. As a result, the attack can execute malicious code in host machine by using virtualization system API, control other virtual machines, or penetrate the internet. We can clearly see that hackers heavily rely on vulnerabilities during the process of launching the get machine escape attack. So whether or not there contains big amount of vulnerabilities in virtualization system, after analysis, I believe that hardware device simulators can be used as an attack surface. So what's the operation principles of device emulators? I will take network card emulator as an example. Network card data packet transferred from virtual machine to internet. Its procedure is one typical inside-out data flow. Several security risks will happen while dealing with this procedure. The whole procedure includes 5 steps. Sending out network data packet by using sockets and functions inside user space of guest machine. Later on, the system follows will step into kernel space and system kernel components related to TCP, insert decisional and third-part info into network packets. After that, the system kernel components related to IP insert, destination address, and source address into network packet. After that, data packets enter into device driver components. Then follow into network card emulator and adapter of a virtualization system. Finally, data packet enter into physical network card through host and be sent into internet. From the above steps, it's clear to see that data packets will be added additional info after every steps. We are inspired by this situation during discovering vulnerabilities. We take advantage of this process to alter the data which entered into device emulators. And this will help us to determine its rootedness. Why we say that hardware device emulator is an attack surface worthy of concern. First, there are different kinds of hardware device emulators. For example, in Qinghao, there are more than 30 device emulators and more than 20 in VMware service product. Second, this emulator connect guest machine and host machine. Third, we could add malicious code inside of those components' memory. Then execute the code. This will lead to really dangerous vulnerabilities. Before proceeding further, let me go through the difference between vulnerability discovery in hardware device emulators and traditional targets. Let me make a comparison to explain it. Normal vulnerability discovery inside user-level software such as AI, Flash, and Nginx, or driver components in kernel space. While virtual vulnerabilities fuzzy mostly target at hardware device emulators with physical device functions like network card emulators, keyboard emulators, and so on. Second, testing way seems more particular in virtualization fuzzing framework. For instance, a web page can be used for IE fuzzing. A remote network packet can be used for Nginx server fuzzing. Our control function core can be used for drivers fuzzing. However, we can't even use any of this data in hardware device emulator fuzzing. During the process of developing and using this fuzzing network, we found more than 20 security vulnerabilities. Here are the part of CV IDs for those vulnerabilities we have made public. So I'm confident with the fuzzing framework can work efficiently in discovering hardware device emulators vulnerabilities. As I mentioned above, heavily used cloud systems hardly can be seen as secure. Compared to traditional IT frameworks, virtual machine escape is a new kind of attack method. According to the attack method, I designed a set of semi-automatic fuzzing framework which realize both discovering vulnerabilities in device emulators or virtualization system. I will start my discussion in the following parts about the operation principles and implementation details of the fuzzing framework. Before starting more details, we need to know that as a testing project for virtualization system, the attack surface we focus on is hardware device emulators. We have finished testing work to several components within Qinghao and VMware Workstation, and found 25 security vulnerabilities until now. The biggest challenge we faced is that it's hard to test the target components of the bottom layer. Then let's see what's the best way for testing in hardware device emulators. At first, it's necessary to analyze the data which be sent to the components and is a process of generating and transfer. Second, set out the test data to target modules according to the devices which could be tested through guest machine data flow. We have two ways to construct testing data. The data process are one way is to alter the content and order of the data transmitted between the driver modules in kernel space at system runtime. Another way to modify the initial state values of those device emulators while the system is starting. About devices which not be tested directly, testing data must be determined and limited by modules from more than one layer at first. Third, recording all of tiny abnormal activities which the hardware device emulators are dealing with testing data. First, in view of those abnormal activities, finding and trace that cause the issues, and in the end, optimize the filing framework by the log and other process data. When I started working on the project, I have already considered about it flexibly and compatibly. For example, utilizing modular way to realize several functions like testing, monitoring, analyzing, and we also make sure our testing framework could run in multiple virtualization systems like VMware, Workstation, Qinghao, and Qinghao in the Zen. During the development process, I use Linux as a guest machine operation system and Python to realize data transmission between the three power and manage guest machine operation. Use C language to implement Linux driver components in guest machine, and XAML was deployed to storage format for testing data template storage. While enhancing the capability, we want to make sure that unification between filing framework and the testing data of specific target. Therefore, we need to optimize our framework according to the different targets. This will need us to consider language we use, develop environment, even coding style, while developing hardware device emulators. For instance, for VMware series software, developers pay more attention to extreme conditions. When an abnormal situation occurs, the main method for exception handling is directly exiting the software. According to Qinghao, less extreme conditions are processed in devices emulator, and the coding styles varies. As shown in the figure, you could clearly see each component and their data flows. We divided the framework into three parts: the host machine, the virtual machine, and the control center. And all the three components are running in every part. We call them monitor, client, and the server. Every part consists of a number of functional modules. Server, which is installed in control center, it contains test case, template database, log database, and log analysis module. Client is installed in virtual machine. Client contains devices emulator, analysis module, system hook module, and testing data log module. Monitor is installed in host machine, and it contains weather instrument module. In addition, a log record module and data communicating module are in every part. Let's talk about server. The server programs are running in controlling center server. Three programs work semi-automatically by control the host testing processes and collect data of every above steps. Security engineers' duty and analyze testing results and optimize hacking data modules. Here are some noteworthy function points. The first one is that some vulnerabilities will cause crash of host machines. Therefore, we need to pay attention to timeout happen and recovering the testing environment of virtual machine timely. And the last one is that maintaining the testing data and related logs in higher. These modules will work as the following sequences. At the beginning, setting up network and hardware environment, launch server, client, and monitor. After that, client will allow system hook module get all of the device emulators basic information. Then client will ask server for testing data of emulators. Server will send out the required data. Client received and loaded the testing data, then launching test. At the same time, monitor will continually check the hardware working and record down logs. After about steps, the testing client finish, and client will notify the server. And the server will get logs from client and monitor, save them into database. Then server will launch log and analyze module, determine if anything wrong happened, and notify the security engineer. And in the end, security engineer will analyze program exceptions, optimize the filing framework. Client program is running in the virtual machine, and the main function of this program is to get hardware virtualization component information. The operation principle of client is emulating the device manager of Windows, and the index of the related information of hardware device emulators, including device name, accessible memories, and ports. All this information are determined by the driver module while custom machine operation system starting. And in Linux, this info are stored in files, and we can use the lspci command to get. However, there are several levels of hardware device simulators. We could only say the top level in device manager. A client program will use the test data from a control center. Test data contains access entry of the technical components, receive data structure, and the restrictions set from its component to field of data structure. First, target components receive info from virtual machine through I/O port and I/O memory. Second, different target components fit different data structures. And later, I will analyze two kinds of network cards, which are E1000 and PCI. It's clear to see that different network cards, their data structure are totally different. Third, same kinds of hardware device simulators play similar roles in different virtual machines. Meanwhile, field restrictions of data structure in VMware and QML are different. We need to define two sets of limited range for a related field. Sending out testing data to target components is already similar process. The first step is that a user layer of client generated testing data sends requests to client kernel according to specified operations from data. The second step is that client kernel applies for memory according to the request, fills out memory, and sends out memory information to specified parts. And as we can see, the main functions of client program are getting target components, generating testing data, sending test data. Additionally, sends logs to server of controlling centering type. Now let's move to monitoring host machine. Monitor program realize functions as follows. The fourth one, managing virtual machines like snapshot management, power management of guest machine, features management of virtual machines. The second one, dynamically debugging the running process of guest machine, such as debugging of launching guest machine, landing the debugging scripts, record debugging info. Third one, keeping record of guest machines running process include recording running process of user layer and the drive module of kernel space. There are other things monitor will do here. When testing QML, we can set up guest machine hardware device simulators by modifying software parameters. And we can modify the QML source code for recording the process. When testing VMware workstation, we can manage virtual machine hardware device by modifying configuration files. The debugging method is that use win debug program to load main process of VMware workstation, and then load debugging scripts for recording running process of virtual machines. Test symbol will cause 3 responses: guest machine operation system crash, virtualization system crash, and invisible results. Guest machine operating system crash happens when there are issues in driver modules because of the system adaptation issue. And this won't help us a lot. We pay more attention to guest machines, crash, and invisible results. Usually, we will find vulnerabilities by analyzing them. For guest machine system crash, it's more obvious to be detected, and it's often caused by serious vulnerabilities, which are triggered in vulnerability system, virtualization system, such as heap overflow, double free, or use after free, and so on. And the invisible results only can be recorded by analyzing guest system logs. In monitor program, we need to use advanced debugging skills to help security engineers to find new security issues. Automatically recording details of virtual machine running, especially changes of key values, and it's really necessary. Based on the record, we can estimate whether there exists information leakage or other logic vulnerabilities or some other vulnerabilities. The instrument techniques vary based on if there exists symbolic information or source code in system we test. As for software without source code or symbolic information, just like the VM workstation, we adopt another method to implement instrumentation techniques. At first, we reverse the software information, location, the key code, and variables. Then we insert breakpoint to critical point when writing the debug plugins. At the beginning, when we use this framework, we got many crashes in short time. However, after digging out relatively simple vulnerabilities, how we gonna find with more complex issues? At that time, we thought that we need to optimize the filing framework. Because of our method of virtualization vulnerabilities discovery by filing heavily rely on accuracy and diversity of testing symbols, and in most of cases, accuracy and diversity of symbols contradict with each other. So we may need massive symbols and testing results in detail to optimize testing data generators, especially the coverage area of target code recording monitor logs. And this testing record can help us optimize the testing data. By analyzing the client logs, we could decrease invalid combination during the testing data generation. By analyzing server logs, gathering and analyzing testing parameter and crash parameters of data templates. And however, we need to note that the danger of hardware device simulator vulnerabilities are limited. Process memory permission in host will determine the effect of vulnerability exploitation. In the permission, if the permission is not enough, not many exploitation operation can be deployed. Then we may need permission escalation by using other abilities. And we could see that this testing project will focus on testing more kinds of virtualization systems in the future, such as Hyper-V and VMware. We will also add more attack services, fuzzing functions. More efficient fuzzing modules have been added in the virtualization fuzzing framework. For example, HyperCore and What Core and the guest machine client. We believe that the framework will help us find more vulnerabilities in the future. And when the fuzzing framework can carry basis virtualization system attack surface, and multi-member can use this fuzzing framework and find more than 50 vulnerabilities, I will make the framework become an open source project. And now I will show you two cases about how hardware device simulators working and vulnerabilities within the these two components realize functions of network card. Like I mentioned before, data packet in guest machine get into host machine. The access internet through host physical network card by helping with this network card emulator. Now let's pay attention to the operating principle of gigabit network card emulator. In the first place, the operating system selects corresponding driver according to the type of network card when it starts. Then drivers will distribute I/O ports, map memory address, initialize device status, and allocate memory resources for descriptor table. After the operation system started, while the data is being sent, the network packet will enter into device driver components. Afterward, device driver components will insert data into the descriptor and set TDT register of network card to be true. When the gigabit network card detects that TDT register has been resigned, and it will process the descriptor table. There are three steps of descriptor in descriptor table. There are context descriptor, data descriptor, and legacy descriptor. According to the descriptor location and content, a gigabit network card will extract the network card info and send it to a virtual device adapter, after which the TDT register will be set first. And after that, whole data packet transmission process finished. There are 2 points we need to pay attention to here. The first one is that the descriptor is one of the ring-like memory. When data size exceeds in the length of descriptor table, it will be overwritten from the beginning of the descriptor table. Due to this reason, buffer overflow will not occur. The second one is that gigabit network card use TCP segment offload technique to improve passing rate of network packet. Due to its complicated logic, there may exist vulnerabilities in the source code of network card emulator, which is related to this technique. And we found two vulnerabilities by means of this filing framework while testing the gigabit network card emulator of QEMU and VMware Workstation. These two are in similar principle. We are able to control the kernel component of guest machine's operation system. Hijacking of code flow is possible by setting several variables of code. The second component is PCNI network card emulator. Although the way that PCNI deal with descriptor are totally different from E1000 network card, but they are doing the similar things, like dealing with data packet info, then send this info to bottom layer adapter from for further steps. Internal process flow of PCNet show as this figure. By means of writing ports, PCNet components capture the operation of writing control and status register. Then it will get into the function we wrote for dealing with the data transfer. Then the component will separately get into process of sending and receiving data packet. During the whole processes, an interesting detail is that adding a CRC after data packets. And we found one vulnerability inside the code of PCNet dealing with received data packet. Attackers could cause buffer overflow where constructing descriptor. And what's exciting is that we could overflow the constructed data to function pointers, and this will make launching guest machine escape attack possible. And today, discuss about the virtualization system filing framework used by my team. And we will continue to working on this filing framework to make it more efficient and accurate. I hope my speech could bring you some new thoughts, and please stay tuned for our more achievements in virtualization system security field. Thanks for patiently listening, and welcome to contact me through the bio email. Thank you.
Thank you, Qinghao. Are there any questions? Yes.
Hello, you're talking about abnormal functions if you get the logging back from the client. How do you get it is abnormal?
Can I speak slow? The client and what?
You get testing results, and you show in the slides that you get abnormal results. How do you get that is an abnormal result? What is the difference between normal and abnormal?
Normal and what?
An abnormal.
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 Sorry.
Abnormal. The normal server and the abnormal server?
The behavior of the client.
Behavior. Maybe you can send me an email. I will answer the question.
Other questions? Yeah, in the back.
Hello. I was curious to know how efficient it was to do some fuzzing on your VMs. Because like for instance, when you have a crash, you have to restore the snapshot or rerun the VM, so I was curious to know how fast it was.
Sorry. In here, I can't hear more info. Can you speak another time?
So I was asking to know how efficient it was to have a fuzzing framework on VM. Because like for instance, if you have a crash on your VM, you detect abnormal behavior or whatever, and then you have to restore the snapshot or restart a VM for every piece of data you're feeding it. So how fast it is?
How what?
Because for sorry.
How long? How much time? For different vulnerability, the time is different, so I can't say how long.
About the fuzzing logic, you started with a fuzzing logic at the base, and how do you get more or a better fuzzing logic data? You understand?
Sorry.
You have a base fuzzing logic you started with.
Fuzzing what?
You told us about you starting the fuzzer,
Yeah.
and you have to get in a base data fuzzing files or
Base data.
Yeah.
Yeah.
And the next run you do it, you get another fuzzing data better than the first one. How do you get that?
Maybe you can send email. I will
Sorry.
tell you more info.
S 平平 Chinese，我复述一下，就是刚才的问题。
Yeah.
一个就是一个 normal 行为和 abnormal 行为，你是怎么来区分的？因为有许多 abnormal 行为，比如说 VM 不能 crash，QEMU 不能 crash。
Okay. Yeah. Yeah. Into three kind of the behavior. The first one is the virtual machine OS crashed, or the second one is the hypervisor crashed, and the third one I call it the invisible results. In second one behavior. Usually, there are some serious vulnerabilities can make the hypervisor crash, and in my test, I find the UEF and double free or other serious vulnerabilities in this behavior. And for the third behavior. I find the info leakage vulnerability. Okay.
The second，你们的系统这个效率究竟是如何的？你们比如说就25个漏洞，你们就是大约是前后经历了多久
Yeah, from last May, I started the framework, and to this May, I totally find 35 vulnerabilities, and there are 25 vulnerabilities that we have make them public. The CVS, yeah.
然后下一个就是，像发经 就 data 发景，我们更关注的是那个数据的生成 data generation。你们的数据生成策略的 data generation policy，how is it？Okay.
We use test case and template to predict the testing date and change the template and can predict more different testing dates, and we insert this testing date into the kernel module, and when the system is running, the crash will happen, and we will find the vulnerabilities. Okay.
Thank you. We'll start again in a little bit less than 10 minutes, 11:45. Thank you.